Yeah.
cloud computing applications in different industries. Okay, great. So I'm just gonna talk about five items or four topics around cloud computing fundamentals. Although Sir Raymond talked about it earlier, but I'm gonna discuss a little bit about the fundamentals, and then we'll talk about an infrastructure, how infrastructure for the cloud is built, and so that you'll get an idea on how massive and how scalable the cloud infrastructure is in terms of its global scope and scale. And let's talk about cloud services in terms of the core services. Around 90 or 80% of the workloads that are running in the cloud are supported by or are run on these services. And then I'm going to share about use cases in the real world and industry examples. Okay? So, cloud computing. So back in the 1980s, or even the invention of computer, we started as different architectures of computing. So 1960s to 70s, we have mainframe, right? And then it evolved into in the 1980s to client server model, which is what I'm showing right now is fundamentally the how the computing world or in the business world has been implemented. So when a client or a client device, any device, your tablet, your PC, computer, laptop, request something, a resource or a web page. For example, if that's a web server, on the other hand, a web server will respond and fulfills the request. So similar to other applications like email, diba? We're familiar with emails, databases, search engines, and other types of applications out there. Basically, this is the fundamental architecture. So there's a client and there's a server somewhere else that's serving up those requests. So this computing model is actually the fundamental concept for enabling cloud computing. So what is cloud computing? So in another simply put definition of cloud, it's an on-demand delivery. So we have keywords here. Please take note. On-demand delivery of IT resources over the internet or some sort of network connectivity with a pay-as-you-go pricing model. And you can access these services. So what are these services or resources? We know. So compute, power, storage, databases, networking. You access that as an as needed basis from a cloud provider. And we'll talk about more about these services later on. So instead of buying and owning and maintaining physical data centers and servers, you just access this on demand. So these are the characteristics. So previously we have the pre-test, no, to check on your knowledge. So just remember these are the characteristics. So on demand, and you only be paying for what you use, and provision the resources as needed for you to avoid upfront investments. So I would say cloud is leveling the playing field because cloud computing allows you to access the same resources, the same technologies that large businesses were able to access. So even the startups, even individual developers or hobbyists, enthusiasts can access the same resources, the same technologies as other large companies or large enterprises out there. So that's why really cloud is the enabler of digital transformation and also leveling the playing field for everyone. So Sir Raymond talked about the cloud deployment models earlier. So I'll just breeze through the concept. So basically, how we deploy IT falls under these three deployment models. First is on premises. This is the traditional sense that we're in. Um, Companies will deploy resources on premises using some sort of virtualization technology, and the infrastructure is owned and managed by the single organization. So, meaning everything from the facility, the space, power, and cooling is uh, being owned and managed by the organization. And on the other hand, in cloud, you deploy the resources on an infrastructure managed by a cloud provider, such as AWS, Azure, or Google Cloud, or other cloud providers out there. And it's about migrating your existing application, or you may have workloads on the on premises and moving it, migrating it to the cloud, or building new applications, workloads in the cloud. So in other words, this is the public cloud. And when we say on-premises, sometimes we call it private cloud if we're doing some virtualization technologies and implementing some sort of a private cloud infrastructure. And then if you want to connect these environments, so that's where hybrid comes in. So it's integrating the internal IT resources with cloud provider infrastructure and services. So this is what we call hybrid cloud. And there's a lot of use cases why would we do hybrid cloud, especially in the industry. So in the later slides, I'll be sharing some of those use cases and why hybrid cloud is still very relevant and very important, even in the era of a cloud computing. And then there's computing models, or in other words, service cloud service models. So earlier we talked about IaaS, PaaS, or SaaS, infrastructure as a service, wherein in IaaS, it contains the basic building blocks. And then for basic building blocks of IT, or IT infrastructure in the cloud. And then there's some level of abstraction, meaning the more customizable, or more responsibility, more control that you have want to have with your infrastructure, you may want to go with IaaS, or infrastructure as a service. But if you want less responsibility, lesser control, but more best practices built in, and easier and faster deployment of your applications, then you may want to consider platform as a service or software as a service. PaaS, or platform as a service, removes the need for the individuals or the businesses to manage the underlying infrastructure, and focus on developing the application and building your applications on top of the cloud. And then for some, you just want to consume, or readily use the application. Even building or coding for the application, you don't need to bother, but you just want to use right away. So this is what the service delivery model of SaaS, or software as a service. So let me illustrate what I'm trying to discuss, or to share. So typically, on a traditional sense, on-premises infrastructure, everything from the data center facility, meaning the space, power and cooling, even the physical security for your data centers, is managed by or handled by the organization, up to the different stacks in the technology, starting from networking, your storage server, the virtualization, the operating system, some middleware or runtime, and then the application itself, and the data that you put on top of, or use or utilize or generate with the applications. With cloud, with these IaaS service models, PaaS and SaaS, some of the I would say the undifferentiated heavy lifting of building the data center facility, configuring networking, storage server, and even virtualization, and managing all these resources, or this the stack in the technology stack, is offloaded to the cloud service provider. Instead, you would focus on the infrastructure that's built on top of the facilities. And then moving up in the stack, meaning more abstraction and more responsibility by the service provider rather than yourself, so that you can focus more on the building of application and data. And then furthermore, on the SaaS service model is everything is provided, even the application. We just need to use and probably uh, put your data into use. So on the left hand side, you have more flexibility and control, but you still have overhead on managing some components of the technology stack. On the right hand side, there's more best practices built in, so that you can focus more on what's really the value or your differentiator. For businesses, it's always about what's the key differentiator, what's the advantage of your company, your organization, compared with other companies within your industry or within the segment or the market that you're operating. So it's always about that. So what's the differentiator for every company? It's always your data, it's your applications, it's the value that companies provide to their customers. So that's why many organizations are moving to the cloud, because of this value that they can get out of moving from legacy or on-premise architect infrastructure to the cloud. So let me talk about a little bit about the uh, trends in computing evolution. So before, it's the traditional is building your infrastructure using physical servers. So you buy hardware, and in the industries, typically you talk to several vendors, hardware vendors, and then you procure, and it takes about several months to a year before your hardware gets shipped to your location, and then you configure, then you test, and it takes so much time and effort before you realize your application to be deployed. And probably with that time spent, the requirement from your business users, from your customers, might have changed already. So, and one drawback of building on physical server is because um, researchers or even practitioners, system administrators, uh, observe that using the physical server, it's really less efficient. A lot of resources has been used, and when they use run the applications on these physical servers, it would only utilize less than 10% of the actual resources of the machine. That's why um, people built virtualization. The purpose is to increase the capacity and as well as increase the efficiency, right? And virtualization allows for running multiple operating systems within one physical machine. And then this is not still enough, because there's still some inefficiencies, and for some who want to focus more on running the applications and testing it on their machine, and then when they run the applications on the production environment on a different machine, sometimes they, or most of the time, they get issues. So it runs on the issue of it runs on my machine, but that doesn't run on the other machine. That's why containerization or containers were developed, so that the applications can be packaged and run in a predictable and repeatable way across multiple environments. So you'll be sure or guaranteed to run your application to run on different environments or different platforms. And there's still further evolution to this, wherein uh, we just use functions instead of provisioning infrastructure or managing the underlying infrastructure. It's a way to build and run applications and services without to manage the infrastructure and using only the resources as you need it. So this is a really true definition of cloud computing. So serverless doesn't mean there's no servers that run the application, but instead you don't have to manage the infrastructure yourself. Instead, run the code, run the application as you need it uh, for a certain period of time, and then you will only pay for what for that amount of time that you use the application. That's what serverless means, and it allows for different application architectures, serverless or event-driven architectures because of serverless. Okay, so let's talk about the benefits again. No, I want you to think about these four main benefits of cloud computing. So earlier, I saw some questions about what are the advantages versus the on-premises. So I would say these four you can say are the uh, top benefits or advantages of cloud. So one is agility. So you can quickly provision, you can innovate faster. So for startups, no, or even the large companies, you can innovate faster because you can experiment frequently and test new ideas without breaking the bank or incurring a lot of cost. So you can fail fast at a lower cost, and you can experiment frequently. You can iterate, and because of the nature of quickly provisioning, how cloud is provisioned, you can have a server. You can already have an environment within minutes. So that's allows for agility. So it will increase your agility. So you can, if you have a project, if you have an application, an idea that you want to build, you can have it faster. You can go to market faster with cloud. And then elasticity. So this is one of the questions earlier. It provides, you can easily scale up or down the resources as needed because of the technologies that's built on cloud that allows you to automatically scale up your the resources depending on the demand or the user traffic, and then scale it back down whenever the traffic is down or no the demand is off peak. So you don't need to over provision. Unlike with the traditional on-premise, you have to think about the peak and the increase in demand in the future for the next 3 years or 5 years down the line. But with the cloud, you can start small, and then you can just provision. You can just increase the capacity as the demand or the need arises. So stop guessing capacity already. You can start small. You can start small, and then you can just knowing that you can just scale up or grow eventually in the future. Then it can also improve reliability. So with cloud, with the massive scale of and presence of the cloud data centers around the world, you can deploy workloads leveraging those the high availability that it can provide. So you can deploy workloads in multiple physical locations without you building the data centers, the physical facility yourself. So you can expand if you want to expand in other markets other than the country that you're operating in. You can expand easily in minutes. I'll demonstrate later on why. And then, of course, this notice the cost savings benefit. I put it last because it's 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 a given that you're trading fixed expenditure or capex for a variable expense or opex. So instead of buying upfront very expensive infrastructure, data center infrastructure, you can use the other funds for your other projects, and then you can just pay for only the resources that you need. Think about the utilities. So when you flip the switch, then that's the only time that you will be paying for the electricity. Same as water. If you open the tap, water flows in, you are metered. There's a meter, and then you will charge for the consumption. Similar for cloud. How much resource you use, it's that's the only time that you will be charged. If you don't use it, you won't be paying for anything. So and also leveraging the economies of scale. So these hyperscale large cloud providers, they typically buy in bulk from these original equipment manufacturers, their servers, their network. They even build their own technologies around servers, networking, and storage. So they can really get the huge amounts of discounts, and this they can pass this discount to customers. That's why you will be enjoying the benefits of lower cost versus the on premises. Of course, there's also cost optimization that you need to do for you to be very much cost effective versus the traditional on-premise infrastructure. So now that we know about the benefits, so with cloud, organizations can focus more on the business differentiators. Again, your core competencies, um, what differentiates you among the competition, and not the infrastructure. So you can focus more on what drives and gives value to your customers or to your users. So cloud enabled some of the innovations that we know. So virtual working from home, which is mainly powered by cloud computing. So we experienced naman in the past few years during the pandemic, and then video streaming, how we consume content. Before we used to rent DVDs, and then we play it with our devices. But nowadays, we just subscribe to a video streaming service. And then also, cloud is also the enabler of digital transformation. So some services that are already available today is enabled by cloud computing. For example, the fintechs, your mobile wallets, digital banking, and even VR or reality, video conferencing, and among other things that are very useful and helpful in our day-to-day lives. And essentially, anything that runs in scale is been enabled by cloud computing. So think about born in the cloud companies. So when I say born in the cloud, so these are services or companies that uh, built or developed their services on top of a cloud environment. They didn't start building a large data centers or buying servers themselves. They go straight to cloud, build their application, and very agile, in a matter of months or even weeks, they're able to deliver the services. So companies like Grab, for example, so they are a leading super app in the Southeast Asia. So they started as a ride-hailing app and eventually built a lot of services on top of that and integrated it to become a super app. So it's very hard to think life nowadays, especially in the urban areas, in the large cities, without thinking about how to book a ride with Grab, right? And other ride-hailing apps out there. So they don't own the fleet, the vehicles. They just build the platform. Another example is Airbnb. So they're the world's largest accommodation provider, but they don't own any real estate properties or hotels or apartments. But they built again a platform on top of a cloud service or environment. Then, as mentioned, Netflix. No, everyone I guess is familiar with Netflix. So it's really hard to think back without Netflix how you consume movies, uh, television shows, documentaries without thinking about Netflix. And then Twilio is it's a cloud communications company. Essentially, this company provides the underlying technology behind some of our most more popular messaging apps and communication apps, and even integration with our telco providers with third party or over the top applications. So Twilio was the company that enables that, and they did not build their telecom infrastructure but they just leverage the cloud technologies. And then Canva, they disrupted the um, I would say the graphics design software. So usually, typically, we install software. We buy the software, buy the license, and then we install it in our machines. But with Canva, they allowed it to be accessed via the cloud. So any web browser, even on a tablet, you can access the graphics software, and then you can build beautiful graphics presentations, uh, images using their service. And then lastly, Meta. Meta is the company behind our social media platforms like Facebook, Instagram, and WhatsApp. So though they have their own sets of data centers, but because how massive their user base is, they still need to rely with other cloud service providers to expand their footprint, their capacity. So these are the examples that the foundation, how they built on top of cloud, allows them for becoming disruptive in their respective industries. So let me talk about the infrastructure, and allow me to give an overview about AWS. So AWS is Amazon Web Services. So it's the world's most comprehensive and broadly adopted cloud for building reliable and scalable and secure sophisticated applications. Think of it as your parang a container or a platform or a stage wherein you need, if you want to build something, you have the set of tools, services, and capabilities that allows you to do that. For example, think about Lego building blocks. If you want to build a house with different components, with we call building blocks, you can build a house. And the same building blocks, you want to build a house, a car, you can also do that. AWS is also like that, wherein um, AWS has 200, more than 200 fully featured services with a deep set of functionalities that will enable you to build virtually any workload or application that you can think of. And then with a massive global reach, AWS has regions and availability zones. So I'll discuss in a bit what are these regions and availability zones. But think that it's present around the world with massive reach, and presence around the world. And then in terms of security, because with AWS, security is job zero, meaning it's a top priority for everyone in AWS. That's why AWS built more than 300 security services and features and tools to help you elevate the security in the cloud. And to attest to that, AWS has 143 security standards and compliance certifications, be it from international standards, even regional or country specific regulations and certifications. And then we work with more than 130,000 partners around the world. So why partners are very important? I'll talk about it in a while. So talking about the infrastructure design. So in AWS, we rarely discuss or talk about data centers anymore. Rather, we have AWS regions. So it's just a physical location around the world wherein it comprises of availability zones. So availability zones consist of one or more data center, discrete data centers. So imagine, so think about how this design, this construct of the cloud infrastructure is built. When you think about uh, disaster recovery, business continuity, high availability, fault tolerance. So in one AZ, there are one or more data centers. So if one center goes down, or if one AZ for whatever reason goes down, there are still two or three or more availability zones that will still continue to operate and still support the operations. So in AWS, it's a minimum of three availability zones in a region. That's a minimum. And even in some regions, in the US, in Japan, there are more than three availability zones in one region. So, and in I just want to highlight, in one between these availability zones, it's fully isolated infrastructure. So para siyang standalone, wherein it's the distance between those availability zones is within 100 kilometers. So it provides isolation from power failures and even disaster floodplains. No, remember the incident a few weeks back or a month ago, wherein in Metro Manila there's massive flooding, and if you put all your data centers in that one vicinity, imagine if how what's the impact of all those data centers were affected. So AWS designs it in such a way that it prevents massive impact in case of those incidents or disasters. And then um, and it's also close to each other in such a way that when you need a very low latency uh, network traffic between those AZs, it allows you for single digit millisecond latency for data replication between the availability zones. So this is the design that's even recognized by Gartner as the best practice for designing a cloud infrastructure. So AWS is not only building AWS regions like with availability zones, but also pushing the cloud further to the edge, meaning closer to the users. So we have also what we call local zones, wherein it's an infrastructure type deployed in metropolitan areas or large population areas or industry centers, and it's fully managed and operated by AWS. Another type of infrastructure is AWS wavelength, wherein this is deployed on uh, telco network operators' data centers, so that it allows for very low latency applications like Internet of Things and other use cases that requires very low latency. And then there's also the ability for organizations to build their infrastructure, AWS infrastructure on their premises. So we have AWS Outpost. So Outpost is it's it's a fully managed service, but it's built, pre-built and configured by AWS, and it will be shipped to the data centers of the customers. So it's gonna be deployed locally in those data centers. And we also have uh, Snow Family. So these are ruggedized physical edge computing devices. So moving closer to the edge. So this is now becoming the edge computing platform. And then it's still owned and managed by AWS, but it will be deployed in these far edge locations. And then, of course, your IoT sensors. So it could be this is where partners, hardware devices can come in to operate as sensors or any IoT devices that needs to connect back to the your applications or workloads in the cloud. So to give you an idea, so cloud is actually not the an abstract concept. It's actually very physical. It's a tangible construct. So with the global infrastructure, local zones, so you have data centers. If you can see the image at the bottom, so this is one example of a data center, an hyperscale data center of AWS. And then what's inside are massive racks of servers and storage and networking equipment. And then on the middle, you can see one image of an AWS outpost. So it's a physical rack with lots of rack mounted servers and storage equipment and networking equipment, and it will be shipped to your location if you order the outpost. And then you can the same infrastructure, the same services, the same tools, in a consistent experience, how you would manage the resources on the outpost as you would manage it back in the region. So It's the same tools, the same experience that you will have. And then the same ruggedized devices, Snow family. So these are compute and storage devices that can withstand harsh weather environments. Then IoT devices, and where not only AWS developed devices, but as third party or partner hardware devices. That's why partners are really important when you build an end-to-end ecosystem or end-to-end solution. Okay, so to give you the overview of the infrastructure, so that's the to summarize the cloud infrastructure. So we have 34 regions, and just recently AWS launched the Malaysia region. So in Asia Pacific region, we have Singapore, we have Jakarta, we have Malaysia. Just recently launched, I think yesterday. Apart from Hong Kong, Japan, and in Australia. So I think in AWS we have the most regions within the Asia Pacific, and there's more coming like Thailand, Taiwan, Mexico, even in the European Union. So in the Middle East, in Saudi Arabia. So there's a lot of regions coming up, so that you can build more. You can have more. You can access to more users around the world, and we have infrastructures that are built closer to those users. So talking about services, so we have more than 200 services, and I won't discuss each and every of these services. Important to know that you have in every category, like for analytics, compute, storage, networking. So the basic fundamental services for IT is available. So, and we'll talk about the widely used services only. So for compute, we have EC2. So Amazon Compute, Elastic Compute Cloud. So it's a web service. Essentially, think of it as a virtual machine instance on AWS. And then Sir Raymond mentioned about serverless. So on AWS, we call it AWS Lambda, which functions as a service or a serverless compute that allows you to execute your code without building or managing the infrastructure. And then for storage, we have object storage. Object storage allows you to store different types of medium or formats, documents, images, source codes, videos, what have you. And it allows for different use cases like building a data lake. If you're familiar with what a data lake is, it's a fancy term for a repository of all your data in one single repository, so that later on you can utilize the data on that facility to uh, to build your analytics, gain some insights, and so on and so forth. Then we have RDS, Relational Database Service. It's a fully managed service. So again, the theme here, you can see it's fully managed. It's built for you so that you don't have to worry about the underlying infrastructure, and just focus and worry about the user experience, how your application will perform, how your application will be very useful and relevant to the users. And then lastly, we have networking. So this is where your resources will sit in Amazon VPC. So it's an isolated, highly secure uh, network environment that where your resources will live. And then I'll talk about the Direct Connect service, which is a dedicated uh, network connectivity between the on-premise and the AWS cloud. And this what enables the hybrid cloud setup. And I'm happy to announce, if you haven't heard the announcement last year, DX location is also available in Manila. So you have for some organizations, they connect to the cloud via uh, using an international lease line component of the connectivity. But now you can connect that directly to a domestic point of presence or interconnection point within the Philippines. So thereby uh, um reducing the cost of the connectivity, because you will only be using the domestic side or the last mile component, which our telecom network service providers will be able to support and provide provision those services. Okay, so how do you interact with AWS? So there are three ways. So first is using a management console. So think about the services, no, compute, storage, networking, and you will provision those services. And then using a web UI, using a device, a laptop or a tablet, as long as you have a web browser and an internet connectivity, anywhere, anytime, you can access or the your cloud, your AWS account, your environment. So that's web UI, management console. So another one is if you're more comfortable using the command line interface. So we also have CLI. You can interact, provision resources, manage resources using a CLI. And then if for some of you who are developers here, you can actually use SDK, software development kits, for you to for your favorite programming language. You can interact with AWS. So this is an example of the what the management console looks like. So it's more click and drop sort of thing, how you would manage the infrastructure, your environment. So let me show you an example of a two-tier web application. So it applies to different, almost all workloads out there. How you set it up in the cloud. So we talked about the region and availability zones. So once you decided on which region that you want to build your application, you can set up the VPC or virtual private cloud. So similarly, on VPC, you will have subnets, IP addressing. So how typically how you would manage your network in a data center environment or your own data center. Similarly, in AWS cloud, you have VPC to isolate your resources within your own cloud network, virtual cloud environment. And then that's where you provision resources. So we have a web server or an application server, and then a database server, and then a cloud storage facility wherein you can store content, static content, and it will be fetched by your application whenever it's needed. But and then when you connect to your users, of course, you have to introduce some other components like application load balancing or elastic auto scaling for you to have a true scalable and highly available environment. So this is just an example, very oversimplified architecture of a web application accessed by your users via the internet. Okay, and to add, if you want to connect it to your uh, data center or your on-premise data center, you have your AWS Direct Connect. That will this allows for hybrid setup for your environment. So connect the on-premises to the cloud environment. Now let's talk about use cases. So these are the typical use cases for cloud adoption. So what are these are the drivers of many customers or many organizations why they want to move to cloud. One is data center extension. So I think similar to the use case of Meta, wherein they have their own, they maintain their own data centers around the world. But since they still need more resource, more capacity, and I think for more reliability, they also rely on other cloud service providers to extend their capacity on existing data centers. Similarly, in large organizations, instead of building new data centers, they can go to the cloud to expand their capacity. And then also, they can turn into cloud for building a test or development environment rather than buying servers again or building more capacity in the existing data center, you might as well consider cloud for your test and dev environments. And then disaster recovery, very good use case, wherein um, probably you will still maintain your production environment on your own data center, and then move your DR site to the cloud. So, um, what's the good thing about moving it in a cloud is, because remember it's pay per use. So if you have resources that you can just stop, and then just start it, provision it, or start the resources again when you need it already, when the time comes. For example, DR drills or disaster recovery drills, or an incident that happens that you want to test your DR site. Um, Moving it to the cloud is a very good example or a use case. Then cloud migration. So you have you're building, you have an application that for some reason you want to save cost, uh, offload the underlying heavy lifting, the management of the facilities. Then you can consider migration of your application to the cloud. And then for some, if you have a next generation application or a modern application, a new project, instead of building it on your on premise, you can start building it in the cloud to reap the benefits and the capabilities and functionalities that are available in the cloud. So these are the drivers now of moving to the cloud. Then so question, so what are the workloads that companies build in the cloud? So for some of you are new to in the industry or still studying, typically cloud you would use you would go for backup and disaster recovery. So I would like to emphasize, no, this is one of the most popular use case and the workloads in the cloud. So you can back up your data from on-premises to the cloud directly, or using third-party or partner solutions, which I have examples on how it looks like. And you can replace your tape backups, and for archiving and compliance, you can consider cloud. Another example is building modern applications. So when you say modern applications, uh, you will be employing technologies like containers, using Docker or Kubernetes, and employing serverless, and essentially taking advantage of the cloud native services, or the built-in cloud services that's been offered. And it allows for different application architectures like microservices, event-driven architectures, domain-driven designs when you build the modern applications. Then for some, it allows for DevOps, streamline CI/CD pipeline, uh, and infrastructure as code. So if you're familiar with those terms, it simply means that it's a modern way of developing, building applications, as well as maintaining and operating the environment on a cloud operating model. So in short, that's what the DevOps means. And then there's also business critical applications. So it doesn't mean that it's mission critical application, it has to stay on premises. Some of the mission critical workloads can also be moved to the cloud. For example, the line of business applications. For example, you're a manufacturing, your line of business applications would involve ERP, yung enterprise resource planning, or supply chain management, or manufacturing systems. So a lot of manufacturing companies also move their ERP to the cloud. Some examples, yung virtual desktop infrastructure, contact center solutions, even HRIS, yung Human Resource Information System, DMS, Document Management System, CRM, Customer Relationship Management, all those line of business applications can be moved to the cloud. And even one interesting use case is for a telecom workload. yung OSS, BSS, Operation Support System, and the Business Support Systems, some large forward-looking network operators already move uh, their these workloads in the cloud, and even some are already in the process of moving those in the cloud as well. And big data analytics, so building a data warehouse, building scalable data lakes. So it really makes sense when you put it in the cloud, because when all your workloads, all your applications are already in the cloud, might as well build your data lake or your data warehouse for you to build your business intelligence, data science, data analytics in the cloud. And then it allows for artificial intelligence AI applications and use cases like digital KYC. You know your customer. You notice in some of the fintechs, mobile applications, banking, you're not required to go to the bank physically to have your KYC done. You can do it by taking a selfie with your ID, and then in the back end, a machine learning model will try to validate your image against your available or existing valid IDs. So it simplifies and also streamlines the process. Then a lot of examples like chatbots and even Gen AI. If you hear generative AI, it's very hype nowadays. Um, we have those are one of the drivers or workloads that are the customers are building on cloud. Talking about Gen AI, so let me talk a bit about Gen AI. So it's a type of artificial intelligence that creates new content ideas. That's why it's generative, because it generates. So content, ideas, conversation, stories, images, what have you. And it's powered by, just like any other AI, it's powered by large machine learning models that are pre-trained over internet-wide vast data, and then it's commonly referred as foundation models. So AI has been around for decades. So even in the 1960s, that term AI was already coined. But how come it's just very popular or hype nowadays? Because of this tipping point, massive proliferation of data, availability of compute capacity, and the machine learning innovations. So the capabilities for hardware processing, training, and inferencing has been becoming more powerful. At the same time, it's becoming cheaper. And then data generated is been massive, especially with the social media or mobile apps, our digital lifestyle. And then machine learning innovations like neural networks, deep learning, and all those innovation in machine learning algorithms. So that's why Gen AI has been hype nowadays. So where does it fit? So we know where you have AI, and a subset of it is machine learning. So more on predictive patterns and models. And then a subset of ML is deep learning, and this what enables yung image recognition, natural language processing that mimics the how our human brain works. And then a subset of that is Gen AI. So it's powered by the large language models that's pre-trained. So what's the difference in foundation model? So traditional ML model is you have a task, and you need to and there's a specific machine learning model for each of the tasks. So you have to train and then you deploy. So from a label data, um, train on based on a label data, and then you build a model, and then that model performs a specific task with the size and the general purpose nature of foundation models makes it different. Typically, you will have a pre-trained model, one foundation model, and then it can quickly adapt to different. It can perform different tasks like text generation, chatbots. So even multi model multimodal foundation models. You can also understand images, videos, music, and so on and so forth. That's the power of the foundation models. So that's why it's very relevant nowadays. So some of the common use cases, uh, text generation, that's one. So with just a prompt, and by the way, there's a new skill that is very related to generative AI, and that's prompt engineering. So you have to be good at uh, writing your prompts for you to get a good result or a good response from the foundation model or the large language model. So example for the developers out there, you can use a large language model for code generation. So it will help you understand the code or even write the code for you. And in some others, code completion and even checking for bugs or errors in your in writing the code, and a lot more use cases of video, audio, image. uh, Even I wanted to share my 13-year-old son uh, was able to create a music based out of a Gen AI app. So he just uploaded the lyrics and then prompted the AI for what genre he likes the music to be, and then it spit out a music complete with tracks and a full song, and it really sounds really good. I wish I can share it here, but yeah. So those are examples of what Gen AI can bring. And then in industry, so this is how Gen AI is being used. So we have communication for chatbot, question and answering, uh, media and entertainment. So video game generation, and even for simple marketing collaterals. So you can have the Gen AI build the marketing images for you, even write the write ups, the marketing collaterals for you, and so on and so forth. A lot of use cases. So for helping the business, uh, and even the analyst for data analyst and call center agents, agent assist, and a lot of use cases that will help aid or assist the humans in their day-to-day job or day-to-day routine that that the Gen AI is now trying to also help and streamline and simplify the task for these employees in these companies. Okay, Gen AI. So now let me share an example use case of using backup to the cloud directly from on-premises. So let's say you have servers, and then you have a backup server on-premise. Then you can actually, this is the simplest and the most cost-effective backup solution with using just one type of service, which is S3, or you can copy directly the backup to S3 Glacier, which is another storage class of S3 that it's very much cheaper compared to the standard storage class of S3. So very straightforward. So you can have a scheduled backup regularly. So for whatever reason, there's your data or your data center is down, or some servers are corrupted or down, you can retrieve the backup from your cloud repository. Now, if for some enterprise users, they would require some advanced features or capabilities, and that's where our partners come in, using a partner software such as Veeam, Veritas, Druva, and other leading backup software in the market can be integrated seamlessly with AWS. And this is why I mentioned earlier the importance of having a partner, because it's not only uh, building the cloud native services, meaning the built-in services that's available on AWS, but as well as having to the capability and the ability to integrate a partner offering or a partner solution is very powerful, because I'm not talking only about backup, but as well as other use case like for security. If you have a preferred security vendor or some capabilities for security that's not available in the cloud native AWS service, you can always integrate that in your solution. So in this case, for backup, you can use the preferred backup partner or backup software and integrate with your cloud environment or your AWS account. So um, re- use cases like replacement for your tape, you don't have to change anything. You can have a copy of your tape backups on AWS, stored on the storage facility S3. Then you can opt to choose if you can use the connectivity via public internet, and there's an already a built-in encryption. But if you're more paranoid and if you want a more secure connectivity, there's also direct connect, which we described earlier. Is a physical dedicated network, so it's not using the public internet for you to connect directly to the cloud, or a VPN, site-to-site VPN over internet. So another option, in case you don't really need direct connect, you can opt for site-to-site VPN over the overlay of internet. So that's for backup. Uh, Also, I want to share about a software-defined wide area network, SD-WANs. So I'm sure for many of you here are enthusiasts for networking, telecom. So I think this is one use case for building a SD-WAN on top of cloud, leveraging the availability zones, the regions of cloud to connect multiple sites and multiple branches, not just within the country, but as well as globally. So let's say you have sites like corporate office, you have branches, then you want and mostly if you have workloads already in the cloud on AWS, you can connect it using SD-WAN solution. So using an SD-WAN uh, appliance, or using a partner, again a partner vendor appliance, uh, it's configured as a virtual appliance, you can leverage multiple availability zones for high availability and connect the different branches to your workloads on AWS. So we have direct connect, then internet as options for connectivity, and it's an overlay. So you have devices installed on the branches that's communicating with the hub in the cloud. So again, you don't have to build the infrastructure, and then you can just provision the resources in a matter of minutes, and then you can save costs because you're only using for the traffic, the data, the utilization, the compute resources as needed. Okay, and another example is the cloudification of a telecom network. For example, this is a use case. This is an example of a 5G core. Uh, So your core functions as network virtualization, NFVs, network function virtualizations, that's sitting in the region, so spread across availability zones, and using the network backbone of AWS, it can reach to the local zone. So a local zone, by the way, we have a local zone already available in Manila, and for use cases like low latency and data residency requirements, if you want to process your data in the country only, but you still want to experience the same AWS experience, and local zone is fully managed by AWS, so you can consider moving workloads on AWS on local zones. So in this case, you're deploying the centralized unit for your RAN, Open RAN component on a local zone. and then connecting it via the radio access network, going to the edge location, the edge site, wherein you have the radio units, or even the distributed units. So I'm not an expert on RAN, but this is how, from the perspective of AWS, this is an oversimplified implementation. So another connectivity option is using again direct connect to connect uh, to an on-premise data center. So could be a data center of a network operator, and where you deploy some of the resources to connect to the radio access network, then reaching to the customers through the radio units. So again, you're not building your own data center, leveraging the benefits of the cloud. Again, the four benefits: agility, elasticity, reliability, and cost savings. So those are some of the examples of how you would use cloud computing applications in the cloud, um, on at least from the perspective of AWS. So to summarize, so with your cloud journey, usually you would start a project. So project muna, POC, proof of concept, and then once you understand the benefits, you realize the what's the advantages, the benefits, you can build a foundation. So yun na yung foundation, right? Building the right AWS account structure, account organizations, and best practices already built in. The security and logging audit, all those things when you build the foundation, incorporating the best practices. Then you think about migration. So think about different strategies. So retire if you stay, if you decommission some applications, then retain if you want to retain it on the on-premise. Rehost is lifting and shifting, meaning you don't have much changes on your existing application. You can once you qualify, once you identify that there's no issues, you can easily migrate the same application on the cloud. So that's the easiest one, but the less, I would say, less benefit for you, uh, because it can be the same expense and the same performance. But if you refactor, replatform, that's where the most of the benefit will come in. And especially if you try to modernize, move to cloud native, like the built-in fully managed services, containers, serverless, managed databases, modern DevOps, and that's how you can continually, with cloud, you can continually reinvent. You get the latest and the greatest technologies, and you can always innovate, because you can focus more on what provides value to your customer and not the infrastructure. So that's I would like to highly emphasize again the value of cloud. So talking about the value of understanding the value on AWS, so we have a cloud value framework. So cost savings is just one, but providing staff productivity, because of the admin, you don't have to worry about the underlying infrastructure, focus on the applications. So it's more time for innovation. Then resiliency, lesser downtimes, agility, as mentioned, you can easily experiment and then build the application in a matter of minutes, or lesser time it takes for you to go to market. And then sustainability. This is something I would like to highlight, because um, these hyperscale cloud providers has more energy efficient data centers than a typical enterprise data center would have. So if an organization have aspirations or advocates for sustainability, has sustainability goals, considering cloud already addresses or ticks that mark on the sustainability requirements. And there's a study that AWS is 3.6 times more efficient than a typical IT data center. So that alone it's a good consideration if you're looking at the sustainability goals. So those are the value. And now um, we AWS, you have to build a well architected environment, which is why we have a framework that will that describes key concepts, design principles, architectural best practices for designing running workloads in the cloud. So thinking about operational excellence, security. So these are the pillars: reliability, performance efficiency, cost optimization, and again, sustainability. So security, going back to that, it's job zero for AWS. So if you have questions around which is secure, cloud or on-premises, so again, the answer to that is cloud can be as secure as you want it to be. So it really depends on how you will build the right security, basing on the well-architected framework and considering the shared responsibility model, knowing the demarcation between your responsibility and the cloud provider's responsibility. uh, I think will help you become more successful and more secure in the cloud. And lastly, we have AWS provides free digital training courses. Once you have an AWS account, you'll have access to 500 plus digital training courses at your own time and pace. And then if you want instructor-led training, you can sign up for instructor-led training that's scheduled regularly and to help you get certified on AWS.